introduction of the general formula for solving x. So I'm going to start by subtracting c from both sides. So I have ax squared plus bx is going to equal to minus c. And then I'm going to divide a from both sides. So ax squared divided by a is just x squared. Bx squared divided by a is b. Well, this is plus b divided by a x. And on the other side you have c minus c divided by a. Okay? Now, in order to achieve a correct factorization of this, I have to add a new term, which is possibly the key for doing the demonstration, which is in order to complete the perfect square. So this would be this term, and you're going to see why in just a minute. I'm going to add b divided by 2a, all that squared, to both sides. So b divided by 2a squared to both sides, and I have minus c divided by a right there. Now, as you can see right here, this can be factorized as x plus b divided by 2a, all of that squared. And you know in general that it would be this times this equals x squared, this times this equals bx divided by 2a, but you have that 2 times, so that's b divided by a times x, and this times this is this, so that's correct. And on the other hand, I'm going to do b to the second power and divide that by 2 times a to the second power, which would look like b squared divided by 4a. I'm just doing this squared, minus c divided by a. Now here, I want a common denominator, so I'm going to multiply minus c divided by a, all of the, this is a squared. I'm going to go multiply that by a 1, so that 1 is going to be 4a. So that's 1, 4a divided by 4a is 1, and you have that multiplying c divided by 8. So now we have a common denominator, and we can just do the subtraction as we normally would. So that is b squared minus 4a times c divided by 4a squared. Now I have this to the second power, so I'm going to do the square root of all of that. So I have x plus b divided by 2 over a equals to plus or minus, because that can have 2 possible answers. So b squared minus 4ac divided by 4a squared. Now, I'm going to do that plus or minus. I'm going to leave it up here. I'm going to apply the Powers law, and I'm going to do that square root divided by the other square root. So I have x plus b over a, 2a, I'm sorry, is going to be equal to the square root plus or minus all that, square root of b squared minus 4ac divided by the square root of 4a squared. And we know that the square root of 4a squared is 2a, because the square root of 4 is 2 and the square root of a squared is a. So I'm going to have x plus b over 2a equal to plus or minus b squared minus 4ac, all of that divided by 2a. I just did the square root of that. Now I'm going to subtract b over 2a to both sides. So x is going to be equal to b over 2a plus or minus b squared minus 4ac divided by 2a. Now since they have a common denominator, you have that x is equal to b. Oh, I'm sorry. This was a minus b because I did a subtraction to both sides. This is minus b plus minus b squared minus 4ac. All of that divided by 2a. And that's why you always see that equation in your textbooks, and it solves this kind of equations. And you need to know that if you do this algorithm correctly, you do not need to double check your answer, because as you can see, it has an algebraic background and it will always be true. There will never be an extraneous solution because of that square root.